Venus is a beautiful, elegant planet, seemingly very calm and almost tranquil on the surface, wrapped in a soft cloud like a blanket. From an outsider's perspective, it's clear why it's named Venus, the Roman god of love. But go beneath the cloud layer and you'll find quite the opposite. Scorching temperatures, volcanism, and a crushing atmosphere are what you'd actually find on the surface. There are few places in our solar system more deadly, and its acid-laced environment makes visiting next to impossible. So, what do we know about this beautiful yet hellish planet? More than you might think. I'm Alex McColgan, and you're watching Astrum. Join me today as we delve into what makes this planet unique in our solar system. Get ready to find out everything you could want to know about Venus. Let's start by stepping back a bit to see where this planet fits into our solar system. Venus is the second planet from the Sun, and it's our closest neighbor. Its average orbital radius around the Sun is 0.72 astronomical units, or roughly 108 million kilometers. It doesn't vary much at all from this mean orbital radius, as it's the planet with the least eccentric orbit, orbiting in a nearly perfect circle. At Venus's closest approach to us, it is the closest of any other planet, being only 41 million kilometers away. Interestingly though, this is not when it's brightest in our sky, as when it's closest to us, we only see the night side, as it's between us and the Sun. It is still visible though, as the sunlight refracts through the atmosphere. It's actually brightest when it's a thinner crescent shape in the sky, and when this happens, it is the brightest object we see at night after the Moon. As such, Venus is commonly misreported as an unidentified flying object. US President Jimmy Carter reported having seen a UFO in 1969, which later analysis suggested was probably Venus. Countless other people have mistaken Venus for something more exotic due to its startling brightness. I recently had the pleasure of looking at Venus through a telescope, and remarkably, the crescent shape of it was very visible. With Venus orbiting between us and the Sun, it may make you wonder if Venus ever eclipses the Sun from our viewpoint on Earth. And the answer is yes, but surprisingly very rarely. Transits happen in pairs, the pairs being 8 years apart, but every pair only happens once every 100 years or so. The last transit we had was in 2012, but if you didn't see that, I'm afraid the next one won't be until 2117. The reason for this rarity is because the orbiting plane of Venus is not exactly the same as Earth's. Also, Venus only catches up with Earth every 584 or so days. These two things combined ensure that, although a spectacular and predictable sight, it also means we'll probably only ever have the chance to see it once or twice in our lifetimes. All the planets orbit anti-clockwise around the Sun, and with this, Venus is no different. But unlike all the other planets, it rotates clockwise, or in other words, in a retrograde rotation. Not only that, but it has an extremely slow rotation, rotating once every 243 Earth days, slower than any other planet. This makes a sidereal day longer than a Venusian year lasting 224 Earth days. A sidereal day, if you remember from my recent Mercury episode, which you can check out here if you missed it, is one rotation of the planet. Because of this retrograde rotation, however, a solar day, which is sunrise to sunrise, is considerably shorter, at 117 Earth days. This means you'd experience just less than 2 days on Venus in 1 year. To give you some perspective as to how slowly it rotates, at the equator, the planet is only rotating at 6.5 kilometers an hour. This slow rotation makes it the second most spherical object in the solar system after the Sun. It is unclear why Venus rotates backwards compared to the rest of the planets, but it could be due to a big impact with another object billions of years ago, or tidal locking with the Sun, or tidal effects on the Venusian atmosphere. Its mass and size are very similar to our Earth, hence why it's often referred to as our sister or twin planet. Venus is one of the 4 inner terrestrial planets, and it is a rocky planet. Its diameter is slightly smaller than Earth's at 12,100 kilometers compared to Earth's 12,740 kilometers, and its density is 5.3 grams per centimeter cubed compared to our 5.5 grams per centimeter cubed. This means the gravity on Venus is only a tenth weaker than that on Earth, surface gravity being 8.9 meters per second squared. But this is where the similarities end, because on the surface of Venus, the atmospheric pressure is 92 times greater than that on Earth. That's an equivalent of 1 kilometer under Earth's oceans. The reason for this is because the density of Venus's atmosphere is 93 times greater than Earth's. Fit that amount of gas into a space slightly smaller than what we have here on Earth, and you can understand why it's so densely packed. The atmosphere consists mainly of CO2 gas, and combined with sulfur dioxide clouds, you're left with the strongest greenhouse effect in the solar system, with temperatures of 462 degrees Celsius at the surface on average. This makes the surface temperature greater than Mercury's, even though Mercury is closer to the Sun, and Venus only gets 25% of the solar radiation that Mercury does. The difference is that Mercury doesn't have an atmosphere to retain the heat, whereas Venus certainly does. This means at nighttime, and even at the poles, the temperature remains fairly constant. Venus really is cooking. It absorbs so much heat, but like a thermal flask, it retains it and doesn't let much escape. With an axial tilt of only 3 degrees, it also means seasonal changes in temperature are also very minimal. Wind speeds aren't very high on Venus's surface, only being a couple of kilometers an hour. But because of the thickness of the atmosphere, it applies a strong force on the obstructions, moving small rocks and dust across the surface. On the other hand, wind speed at the cloud layer is much faster, reaching speeds of 300 kilometers per hour. These winds at the cloud tops circle the planet about every 4 to 5 Earth days, which makes the planet look like it's rotating a lot faster than it actually is. The cloud layer itself sits above the thick CO2 and consists mainly of sulfur dioxide and sulfuric acid droplets. Sulfuric acid, just as a side note, is highly corrosive, and this acid rain just adds to the hellish nature of Venus, although it does evaporate before it hits the surface. The clouds on Venus are highly reflective, only allowing about 10% of the sunlight through, and because they cover the entire planet, it obstructs a visual view of the surface from space. These clouds are also capable of producing lightning, much like on Earth, although it's not as common. Recently, it has been discovered that Venus has a large vortex at the South Pole, much like on Saturn. Now, Venus is the image on the left and Saturn on the right. They are shaped quite differently, and Venus only has one storm, whereas, incredibly, every single black dot in the Saturn image is a separate storm, with the main vortex being in the center. The vortex on Venus is at an altitude of 59 kilometers, which is just above the cloud deck. Which leads on to an interesting point about the atmosphere of Venus. Because at about 50 kilometers up, the air pressure and temperature would be tolerable by Earth standards. Even the gravity would feel very much like Earth. The only problem with a person actually being there is the air itself. But if you were to have an airtight plane or something like this, the conditions would actually be very Earth-like. Now, I want to head back down to the surface of Venus a little bit, as we actually have some real photos of the surface thanks to the pioneering efforts of the Russians back in the 60s to 80s. The probe Venera 7 in 1970 was the first probe to ever land on another planet and send back data. The previous attempts resulted in the probe's signal terminating before touchdown. Venera 7 probably fell over on impact, and so the only reading it gave was the temperature at the surface, which was 475 degrees Celsius. Venera 8 confirmed that at the surface the visibility was quite clear, with a visibility range of about 1 kilometer, as the cloud layers end at quite a high altitude, meaning it was suitable for cameras in future missions. Venera 9 sent back the first ever image of the surface of Venus. Venera 10, 13 and 14 over the course of 6 years sent back more imagery, this time in color, as well as a lot of data regarding the conditions of the planet. Since then, there have been a number of probes that have mapped out the surface of Venus. Using radar, they're able to see through the cloud cover and image the planet's surface in very high definition. The surface of Venus is dotted with a lot of big, but not necessarily active volcanoes. It has 167 volcanoes which are over 100 kilometers in diameter. The only complex of this size on Earth is the big island of Hawaii. This doesn't mean Venus is more volcanically active than Earth, but this is due to the fact that Venus has a much older crust than on Earth. Earth has plate tectonics, releasing heat and renewing the surface fairly regularly, regularly being at least 100 million years. Venus, on the other hand, doesn't have any plate tectonics. Instead, its crust is estimated to be about 300 to 600 million years old, when a global resurfacing event likely occurred. The theory is that the mantle under the surface heated up so much that it forced its way up through the crust, covering most of the surface with lava. An incredible 80% of Venus's surface is made up of cooled lava plains, and there are literally hundreds of thousands of volcanoes in one form or another. There are also 900 impact craters to be found on Venus, although none less than 3 kilometers in diameter. This is because anything smaller than 50 meters in diameter would fragment and burn up before it even hit the surface. And finally, let's have a look at the magnetosphere. Venus doesn't have its own magnetic field, which surprised everyone when it was first discovered, as Venus's composition is very similar to Earth's. But without more data, it's hard to say why this might be. Although a study in the journal Earth and Science Planetary Letters in 2017 suggested that perhaps it was to do with the absence of a massive impact in Venus's history. Earth had at least one massive impact. It's what formed the Moon, and it's possible it played a part in kickstarting our magnetic dynamo. But Venus never had such an impact. Perhaps this explains the lack of a similar field. Regardless, as a result of this, solar and cosmic radiation interacts a lot with the upper atmosphere of the planet, producing lightning and an induced magnetosphere. Solar wind also strips off the low density molecules out of the atmosphere, meaning Venus has a tail similar to a comet. Under certain conditions, this tail can tickle Earth when they are in conjunction with each other. Unfortunately though, this tail isn't visible with the naked eye. Sadly, we've come to the end of the video, but I'd just like to say thank you so much for watching this